Oh, sorry. Hello. Um, the first viewers on Twitch and on YouTube, can you hear me? Good. Thanks, Stefan. So Twitch is working. Anybody on YouTube that can hear me? Yeah. Thanks, Jay. Yeah, we have bad history with audio. So always very happy if it's working. Good. Uh, Hello to all around the world. I see Seattle, I see Copenhagen, I see Vienna. Yeah, will be an interesting talk today, and we will start in 12 minutes. So get something to eat, get something to drink, and yeah, see you in 10, 12 minutes. Oh, nearly our usual 6:15 time to start the meetup. Let's let's start the countdown to start. So, hello everyone. Welcome to today's meetup, the April 2022 version. As always, this meetup is presented to you by us, the .NET Devs AT. Thank you all for joining today all around the globe. I saw people from Seattle, Copenhagen, a lot of people from Vienna, Croatia. Hello to all of you. Um, Yeah. Quick, who we are. If you're the first time here, .NET Devs, we're a non-profit organization here in Vienna, Austria, and we all about sharing and um, experience and knowledge of the .NET ecosystem with as much as possible people. We have a homepage, we have a Twitter, we have Twitch and YouTube. You're seeing it here, and we have also a Slack channel where we help out each other. Um, want to thank our sponsors. That is Rubicon and Theater Every for financial support. This makes possible that we use this StreamYard for streaming. Thanks to them for this nice video, some of the features. Also, thanks to JetBrains for sponsoring. They sponsor 12 months product license for every meetup to raffle. And what you need to do to take part in the raffle, type JetBrains in the chat somewhen during the meetup, and at the end of it, we will raffle the lucky winner. Yeah, another raffle what we're doing. We bought some months ago some Hey Friends t-shirt from Scott Hanselman, and we have still three t-shirts to raffle. To win one of them, you have a feedback form at the end. If you take part of the feedback form, you can win one of the t-shirts. It's limited to Austria to reduce somehow the costs of shipping. So sorry for the international viewers, only for Austria. Yeah, quick, some news from the community. Not much this time. We are part of the .NET Foundation, and they have a .NET Virtual User Group, where a lot of user groups around the world are also publishing their meetups. So if you want to have more .NET content as you can consume, check out this meetup group. And quick info about our plans for the future. We plan to do in-person events again in June 2022. May meetup will still be remote only. If we will do it, it will be a hybrid event, so it will be on location and also per stream. Available for the international people. The last point, I need. There's so much changing on this testing thing in Austria at the moment. Let's see what is in June then possible. Our current approach is 2G plus, so vaccines. You had COVID or you are vaccinated 3 times and you have a negative PCR test. Yeah, and that was enough talking from me, and Now it's Steve Pass to talk about .NET Core Dependency Injection. Let's lose the chat.
Yeah.
The title is wrong. We are .NET. They dropped. There's still a core in the title. I just noticed. Copy and paste stuff.
Yeah. Originally, when we talked about speaking, it was still the .NET 5 version, but now I've spent this week and updated it to .NET 6. So a lot of new content.
Looking forward to this. And with that, Steve, it's your stage. Your
Okay,
screen is
I
shared.
will just go and move my screen over. Can you see the screen?
We can see the slides.
Yeah, brilliant. Okay.
Yeah.
Right, thank you, Andreas. Right, hey everyone, thank you for coming along today. I'll start with a quick introduction before we get going. Let me find my clicker. I'm Steve Collins. I've been programming in one form or another since I was a teenager, but I've been doing this professionally since the early 90s, which kind of makes me very old. I started with VB3 way back in the early 90s, and now I'm using .NET 6. As I've got quite a common name, I go by the alias of Steve Talks Code for both my blog and my Twitter handle, and there's links on the slide there. Over the last year, I've also been organising the monthly Milton Keynes.NET online user group in the UK, which you can find on Meetup, and there's a link there. I've got quite a few links in my talk this evening, so rather than sort of having to scrabble around, I've put them all in a GitHub gist, and there's a link there. But also the bit.ly link is down there at the bottom of the screen, and I also put it in the Meetup comments this morning. Now, the subject of dependency injection is huge, and I could easily talk about it for a whole day and still not cover everything I would want to talk about. So as I've only got about an hour or so for this talk, I've had to limit what I will cover today. So as this is a .NET 6 talk, I'll start with comparing the .NET 5 bootstrapper to the newer one in .NET 6. I'll then go on to cover what functionality is and isn't supported out of the box by the Microsoft container. We'll have a refresher of the various dependency lifetimes. We'll be covering avoiding memory leaks by understanding how the container deals with disposable objects. And lastly, I'll be showing how to avoid some mistakes and get around some missing functionality in the Microsoft container using classic Gang of 4 design patterns. So with that, let's go. What I won't be covering is because there's so much, I won't be covering things like console applications, desktop applications, Windows Blazor applications, serverless functions. I won't be covering alternative containers such as AutoFac, and I won't be covering things like migrating from .NET Core 2.1. For that, if you're interested in the last two, my slides are getting a bit behind me. So for those last 2 points, if they are of interest to you, I did a webinar for JetBrains around this time last year that's available on YouTube. There's a direct link there, but you should also be able to find it by just typing into YouTube Steve Talks Code and JetBrains. So, .NET 5 bootstrapping. Before we get into .NET 6, I want to cover the stuff that you should be familiar with from .NET Core 3.1 and .NET 5 that we've been doing for the last few years. And then I'll do a comparison with what's happening in .NET 6, mainly due to the introduction of minimal APIs. So I'm going to assume that you're probably familiar with the bootstrapping process we've had since Core 3, but I want to cover it so that we can do that comparison with .NET 6. So in .NET 5, when we create a new API project, we get two files created for us, namely a program file, like the one we have here, and a startup file, which I'll cover in a minute. In the program file, we have a method that will create a generic host builder for us. We then configure the builder to use the defaults for a web host, and then we tell the web host builder to use a startup class that we will then use to register and configure middleware, register services and configure the middleware for the HTTP pipeline. In our startup class, we have code that you're likely to be familiar with. In this example, we are just registering some classes with the service collection and giving them different lifetimes. But how do these two classes work with each other? As we showed on the previous slide, you start with a host builder that initializes the service collection with some default services. Once it has done that, it will then call your startup class's configure services method. And that's where you add your registrations like we have shown here. After that, it will then call the build service provider method on the service collection to create the container instance based on these service registrations. Once built, the container is then used to resolve instances of services whenever they are required. It's probably better to try and illustrate that inside Visual Studio. So first we have a program class, then we've got a startup class, and then we have a controller with an action method to handle a request. The program has a main method, which is our entry point into the application, and that calls a method to create a host builder, which we set up with defaults for a web application. We tell that method to use the startup class, and that use startup method magically knows how to call configure services. That goes and sets up the dependency registrations. Then once the container is built, it will call configure to then set up the middleware in the HTTP pipeline. Now, lastly, we have controllers that receive and process the request, but in order to do that, we may need to inject dependencies into the controller's constructor. Now, I just want to clarify the difference between the two startup methods. The configure services gets called before building the container. So that's the thing that goes in where we do all our registrations before building the container. The configure method gets called after the container is built. In other words, you can only register dependencies with the container either directly in the host, in the program file, or in configure services. Once you get to the configure method, the container is baked and it can't be changed. But what you can do is consume dependencies in the configure method. So in this example, we have a class called dummy that I've created elsewhere with the single method of do something. First, we register it with the container in configure services. Then we add it to a list of parameters for the configure method. And then lastly, we make use of it within the configure method. Now, this is all achieved with some more magic in the host builder that works out via reflection that additional parameters in the configure method need to be resolved from the container and need to be passed to the method. This is generally known as method injection. So now we have a container set up. What does it support? In short, not a lot. Out of the box, the .NET container only supports injecting dependencies into constructors of classes, and that's about it. But in the previous slide, I said that the configure method was able to get its dependencies via method injection. Now, in that particular case, it is done with some reflection magic in the host builder. It's not supported directly by the container. However, if you're using ASP.NET, you do get method injection support added by decorating parameters with attributes. This time it is ASP.NET rather than the host builder that works out which dependencies are needed for a method and requesting them from a container. But to do this, we have to explicitly tell ASP.NET where to get the parameters from. Now, this could be from the request body, the request headers, or query strings. But if we want that parameter to come from the DI container, we have to decorate it with a from services attribute. Now, if you look at other containers, though, there are other injection types available. But these injection types aren't supported out of the box with the Microsoft container. Firstly, we have property injection. This is where a class has a parameterless constructor, so dependencies have to be set via properties once the instance has been created. Once all the properties have been set, then you can call a method, typically called something like initialize or onStart, something like that, to prepare the object for use. Next, we have named or key-based injection. This is where you identify the dependency you need by some key value, typically a string or enum, for example. Last on the list, we have automated service registration by convention. Now, that's quite a mouthful to say, but what it's basically saying is that the container or some add-in scans an assembly and pulls out all the classes and interfaces to register based on a set of conventions or rules that you specify. The good news is I'll be showing you some workarounds so that you can implement these without having to go and use another container like AutoFact, for example. So that's how things have worked for the last few years in .NET Core and .NET 5. Over the past few minutes, I've used words like magic and conventions to describe how the bootstrapping of a web application works. There's conventions in the naming of methods in the startup class. So we've got our configure services and we've got our configure method. There's magic in the way that the host builder knows how to call the configure method with parameters from the container if it's required. Now, of course, it's not really magic. It's all a lot of clever code using reflection written by the Microsoft people. But to a new developer coming to .NET, it may as well be magic, because why do I have to have a startup class? What's all this boilerplate I have to do just to fire up a web API? That leads us to what's changed in .NET 6. With .NET 6, Microsoft has taken on board some of the criticisms of .NET and C#. When compared to other frameworks and languages, there's a lot of ceremony and boilerplate to get a simple web API up and running. Microsoft has done a lot of work to address this with things like minimal API, global usings, and file-level namespaces. But for this talk, I want to focus on the bootstrapping of ASP.NET Web APIs. To be clear, what we've covered in the previous slides for Core 3.1 and .NET 5, that all still works. It's still valid code, and you can still use those if you're migrating something from .NET 5 to .NET 6. But if you're starting a brand new project using Visual Studio or Rider and using .NET 6, the templates for web APIs have changed. Now, you get the options to use controllers or not, but what we're interested in here is in the introduction of the web application class. Now, it may appear with this, we might have gone full circle back to the web host builder that we used to use in .NET Core 2, before we had the generic host builder that was added in .NET Core 3, but that's not really true. Whereas the web host builder was an actual builder for a web host, the web application class is an adapter over the code that we've just been looking at in Program and Startup over the generic host builder. Microsoft's aim with this has been to be able to have a simple API up and running in a few lines of code in your program file, which means you don't need a separate startup class to register your dependencies and pipeline. So if you create a new web API project in VS 2022 and select .NET 6 as a target, you'll get something that looks a bit like this. First, you'll notice we don't have the generic host builder with the web defaults anymore. Instead, we get a new web application static class, and that's got a create builder method on it. Next, our service registrations are no longer in startup. That's just gone. Instead, we have a service collection that is now a property on the web application builder. So that's where you do your registrations on that service property, whereas you would have done them on the service collection that was put into the startup class. We still use the same registration techniques that we would have used in startup, but now we just apply them to that property. So all the things like add singleton, add transients, they all still work against that property. It's still an iService collection. Now in .NET 5, when we build the host, it would also go and call the configure method like we saw earlier to go and set up the middleware pipeline. In this new .NET 6 layout, which is simplified and we don't have a startup class, that magic has disappeared. We're on our own. We have to go and build our web application ourselves. So we go and call the build method. And then we go and explicitly set up the middleware pipeline with the web application that has been set up. Finally, we set up our endpoints in the same file instead of creating controllers. Now, if your web API is truly a microservice where you only have one or two endpoints, that's great. That's really tight. It's very explicit in defining the intent of what you are trying to do, instead of hiding things with magic and going off and building startup classes using reflection and going and calling stuff. It's very terse in what it's trying to do in that. Finally, using app.run and you're off. But if you have lots of endpoints, we have lots of dependencies or lots of middleware that need defining, that file could grow very, very quickly and soon become unmanageable. So whilst the Microsoft examples for .NET 6 minimal APIs do this, it doesn't necessarily mean that you should do it. So with that in mind, I would still take the approach of possibly using a startup class, but the way you work with it differs slightly. As we don't have an extension method to use the startup on Web Application Builder, you have to instantiate the class app yourself. If you want to reference the configuration in startup, you need to pass the configuration property from the builder. That was previously done for you by all the magic in the U startup. The other thing to bear in mind is that some of the things you could do in .NET 5 startup class cannot be done if you're using the Web Application Builder. I won't go through the whole list of differences here, as there's quite a few. The most noticeable ones are those that you cannot change any of the host settings, such as application name or environment, once the builder has been created. I've created a bit.ly linked on screen to the Microsoft documentation that I show here, and it's also there in the talk notes. The next thing we need to build, once we've configured our services, is we need to go and build the actual web application itself. Once this is done, we can then pass that into the configure method. Again, that's replacing what the web host builder used to do with the startup method. Use startup rather. One last thing I do want to mention is about the configure method. Now in .NET 5, if you wanted to access the environment settings, you would have to specify a parameter for the iWeb host environment, in addition to the iApplication Builder parameter if you wanted to get to any environment settings. With a new web application instance that is built into .NET 6, the class implements both those interfaces. So you can make a change to the startup class to only require that web application parameter, and you can access the environment property instead of having to take in an iEnvironment on there as well. Now for the rest of this talk, I want to try and keep things relevant to whichever version of a modern .NET you are using, be it Core 3.1 or .NET 5, but both of those go end of life over the course of this year, or the latest .NET 6. So if you see examples using startup classes, they are still relevant in .NET 6, but if you're using the much more terse syntax of doing everything in your program file, you need to do a little bit of work to change those examples to work directly with the web application builder. So as we indicated with minimal APIs, in .NET 6 you don't need controllers for minimal APIs. It's all there in your program CS. But it does raise the question of how do you inject dependencies into minimal APIs? This comes back to ASP.NET supporting method injection. So we're moving away from constructor injection into controllers to method injection in these handlers for the minimal web API. Well, what is different is that you no longer have to explicitly specify the from service attribute. Here I have an updated version of the earlier example, which is from the default minimal API template project. I've taken the summaries field that was explicitly defined within the main application code. I've moved it out into its own class called weather summaries and just made it a property. I then register that weather summaries as a singleton in my services. And this is where the magic, well, not the magic, where we're being very explicit rather than having magic, in that we're saying we want weather summaries as a parameter into our endpoint handler. As I say, whereas in controllers we're to be explicit about saying using the from services attribute, we don't need to do that with minimal APIs. So to support this, a new interface has been added into .NET 6. The iService provider isService has a single method of isService. Now, it's not very elegant naming, and David Fowler has even gone, what is this naming? But it does what it says on the tin. It returns a Boolean to indicate if a require type has been registered with the container. When that's checked, ASP.NET checks for each of the parameters in the minimal API handler to see which ones can be found in the container. However, just because a service is registered, it does not necessarily mean that it will resolve. It may fail to resolve for a number of reasons, such as problems with other subdependencies. Now, it's unlikely you'll use that new interface in your own code, though it might be useful for some unit tests. Not sure. So, are there any questions so far, Andreas?
No, there are not.
No? Okay, I'll have a quick sip of water and I'll crack on. So let's cover bootstrapping. Now let's focus on the things that are common to DI, regardless of which .NET version you are using. Let's start with service lifetimes. Now, I'm sure this is familiar territory, but I've included it to make sure everyone has the same level of understanding before we delve any deeper. Firstly, we've got singletons. These are created only once and live for the duration of the container's lifetime. Next, we have transients. These are sort of fair weather friends that just come and go as and when needed. And last but not least, we have scope lifetimes, which sort of a halfway house between the two, in that they're created on demand when a scope starts. So they're a bit like transient in that sense, but they're a bit like singleton in that they're longer lived than transients. The thing to consider with these different lifetimes is that some play well with each other and some should be kept apart. So let's break it down. Starting with the shortest lived of the lifetimes, the transient can accept objects for any of the 3 lifetimes. Moving up, scope lifetimes, because they are slightly longer lived than transients, shouldn't have transient lifetimes injected into them, but they can still accept singletons or other scope dependencies. Lastly, as the singleton is the longest lived of all, this should only accept other singletons being injected into it and not the other 2. Now, I'll try to choose my words carefully when describing these relationships because there's a general misconception that it's not possible to inject incompatible lifetimes into each other. That's not strictly true. I can't speak for the other third-party containers, but the Microsoft container won't stop you. If you have a singleton and its constructor requires an instance of something that's been registered with a shorter lifetime, like a scope or transient, the container will happily give you that instance. The problem is the instance you'll get will have its lifetime promoted up to the same as the receiving instance. So a transient or scope would get promoted up to a singleton, for example, when it's first created. The problem with doing that is that once that's been created, it's locked into that singleton and it won't be released until the singleton is disposed of. And that doesn't happen until the container is done and dusted, and it disposes that singleton at the end of the container's lifetime. This is known as captured dependency, where a transient or scoped instance, like the insect shown in amber here, is imprisoned in an outer shell, in which in our case is the singleton. But you may be wanting to pause and say, hang on, when I've done this before, I've got an exception. Yes, that can occur. By default, it only happens when your ASP.NET Core environment is set to development. This is done by some hidden magic that lies in the host builder. However, you can explicitly turn this behavior on by setting on the optional validate scopes parameter to true when the service provider is being created. Now, that is something I haven't looked at in .NET 6 yet, and something I want to come back and look at a later point. But by turning on having validate scopes being turned on, that is a performance hit at startup. So the general guidance is that you don't do it in a production code. You only do it for debug code to try and catch the errors while you're doing a build. Whilst I haven't got time to cover it here today, there's also a validate on build method, and that will help and try and identify registration problems. Things like you're expecting certain dependencies to be registered in a dependency chain and one of them is missing. It's fairly limited in what it can identify as problems, so I wouldn't rely 100% on it. So moving on, given that singletons live a long time and can be dangerous when mixing with other lifetimes, let's consider why we would use singletons and the typical use cases. Given singletons can be accessed from anywhere within an application, things get tricky if your application uses multiple threads. Therefore, singletons should ideally be stateless, so you avoid threading complications. But sometimes you may well have some sort of state that you do need to share. These might be pooled resources, in-memory queues, or some other type where you're in control of a limited resource that multiple things are dependent upon. I'll talk about factory classes later, but typically these are created once, and then their methods are called to create shorter-lived instances of some other dependency when required. You may have an ambient singleton. This hides the complexity of accessing shorter-lived objects, something like the HTTP context accessor in ASP.NET Core. That uses async local storage to avoid captured dependency problems, but that then brings its own problems with it. The last of the cases shown here is immutable state. That's where you don't want to have to recreate a resource object over and over and over again when you know that the data will be loaded when the application first starts running and it will not change while the application lives. For example, you may have some lookup data you only want to read once from a slow repository, such as a database, a file, or a network share. If you really must have state, give some thought to letting .NET do some of the heavy lifting for you. If you've got collections, consider using some of the concurrent collections that are in the concurrent namespace, where the thread safety has already been done for you. For read-only properties, make that underlying field read-only so that if someone comes along later and makes it a read-write property, They only have to do some work. Sorry, they have to do some work. And that will trigger them to think, well, if this is read only and I'm making it read write, what are the consequences of doing that? So it's trying to create a little safety net to make people think before going and just changing things to read write. For those properties that must be read write, you should consider maybe using a thread lock. So in this slide, we can see we're ensuring that all property access is managed by the thread lock. That way we can ensure that the value is only changed by any one thread at a time. Now, you're probably 2 steps ahead of me. The problem with this approach is that by serializing the access to the property, you'll get a major performance hit, as you are forcing everything that touches that property down a narrow one at a time alleyway. So you end up with all the threads being queued up, or even worse, you may end up with thread deadlocks. So instead, you may want to consider whether your design is correct or whether async local can help in some way. I don't have a panacea for this. I'm just warning that this may be a code smell. Lastly, consider the impact of having disposables in a singleton. The problem here is that if you expose the dispose method and the consumer calls it, everyone else who comes in and requests that dependency afterwards has lost access to the disposed resources, which can cause an object disposed exception to be raised elsewhere in the application. However, you do still need to make sure that the dispose method is there for the container to clean up after itself when it's done with the resource. To get around this, consider abstracting the class with an interface that exposes all the members except the dispose method. That way, as the service type is the interface and not the concrete class, when the instance is served up from the container into something that wants it, you've put some guardrails in place because the consumer can't get to the dispose method, not without casting it explicitly to the originating type. And if they want to do that, well, they've shot themselves in their own foot. That's their problem, it's not yours. For transients, there's not really a lot I can say about them. All I would say is just be careful about doing a lot of work in the constructor, as you don't have control over when these instances are created by the container. This could have a major performance hit on your application if they are doing something like going and getting data from a database, making network calls, reading files from the file system, anything that's got a lot of latency to it. You really don't want to put in the constructor of a transient. Rather, if you need to do that stuff in a transient, then try and make it within a method call rather than in the constructor. Let's finally move on to scope lifetimes. Now, these need to be approached with caution and handled with care. In fact, I've seen various blog posts and tweets where people have said that they have banned their use on projects. I think that's a little bit drastic, but I understand their reticence, as it can come back and bite you when you least expect it if used incorrectly. I hope I can clear up some of these pain points now. We've already covered how scoped instances should be used with other lifetimes, but what exactly is a scope lifetime? The commonly quoted answer that you might get is that it's created by ASP.NET Core for an HTTP request response lifetime. But that's not the whole story. Whilst that is a common use case, the scope is not tied to ASP. You can create your own scopes. But that still doesn't answer what a scope is. The scope is really there to ensure that objects are only created once within a single unit of work. So say you have several classes that are all considered to be within a single unit of work. Those classes interact with each other and all depend on receiving, say, an iWidget instance in their constructor when created by the container. Therefore, you want to make sure that they all receive the same instance from the container because they're all contributing to that one piece of work. So in that respect, a scope lifetime is a bit like a singleton in that the same instance is shared between several consuming class instances. However, outside that unit of work boundary, you expect to get a different instance. So in that respect, it's a bit like a transient in that every call gets a new instance. So to come back to the common use case of a web request, if Bill and Ted each make web requests, those request response pipelines are individual units of work and therefore are scoped instances. And they should, each person's web request and the dependencies are confined to that pipeline's boundary. However, as I talked about earlier, it is possible to accidentally promote a scope dependency lifetime up to a singleton if injected into a singleton's constructor. Away from the web, you might be writing a Xamarin or Maui or console application. You might want to manually create a scope yourself. This is done by calling the createScope method on the iServiceProvider instance. This gives you back an iService scope with a single property of service provider, which is an instance of iServiceProvider again. So we're sort of nesting service providers within service providers. But this time you've created a boundary that will serve up scoped services. That's a bit of a mouthful to try and explain just in words. So maybe looking at how ASP.NET Core goes about it might provide some clarity. In ASP.NET Core, the creation of scopes is taken care of for you when the request response lifetime is started. The server will create a load of service features, but the one we're interested in is the request services feature. As I described just now, the scope factory is used to create the scope as highlighted here. That scope is then used to create scope service provider, which is then accessed from HTTP context request services property. As someone writing ASP.NET controllers or minimal APIs, all of this is hidden away from you. You don't really care. All you do need to care about is specifying your dependencies in the constructor or action of a controller or in the handler parameters on a minimal API. However, there is one area of ASP.NET Core where it is worth knowing what's going on under the hood, and that's middleware. When we talk about middleware, we think about intercepting and handling HTTP requests and responses. Now, because of this, you might assume that middleware is a scoped registration. That's not strictly true, as there are two ways of writing middleware. The one that most people are familiar with is convention-based middleware, as shown here. With this type of middleware, you accept a request delegate from the constructor and then call it within the invoke async method to move to the next middleware in the pipeline. So it chains from delegate to delegate to delegate to delegate. Either before and after the delegate call is where you'll do your own work. In some cases, you might be writing terminating middleware, where you generate the response and don't call the delegate unless you cannot handle the request. This is how something like the static file middleware works. If you have dependencies other than HTTP context, you add these as parameters to the invoke async method, and they magically appear when the method is called by the pipeline. But how does this all happen? When you register middleware, it's done in the configure method of a startup, or as we saw earlier, in your web application. At this point, the container is already baked, so you're not adding middleware to the container. Instead, what you're doing is inserting a delegate to the invoke async method. And what that will be doing is the actual work in the pipeline. To do that, a single instance of the middleware class is created by the use middleware method. When that single instance is created, any dependencies are resolved from the root container. Now, as we saw earlier, if the constructor is only called once, when you request a transient or scope dependency into a constructor, it will become a captured dependency. So what you need to bear in mind is that the pipeline is created before the first request. So you won't be able to access anything related to HTTP context in the constructor of a middleware, as it does not exist at that point, because all you've done is created the delegate to point to a single instance of your middleware, and you'll be calling into the method. What will happen is you'll get an invalid operation exception thrown, as it cannot be resolved at that point. It's been because it just doesn't exist. So the point of instantiation to create the pipeline, there's just no HTTP context to use. Other scope dependencies that are not part of the pipeline might resolve, but as I said earlier, they become captured dependencies. So how does this the request that is scoped get dealt with? Well, as the request moves through each layer of the middleware in the pipeline, the invoke async method gets called through each delegate in the chain, and not through some interface or abstract contract. To do this, when the middleware is added to the pipeline, the request delegate is created. The delegate acts as a wrapper over the invoke async method. So as you can see here, the request delegate is passed as a parameter in the middleware constructor to enable the request to be passed down to the next one in the pipeline. You're free to add any scoped or transient dependencies as parameters to the invoke async method if you need them in order to do some work, either before or either the next middleware in the pipeline, because invoke async gets called within the context of a scope. So in the previous example, I demonstrated how dependency injection works with convention-based middleware. What is less well known is that there is an interface called iMiddleware that was introduced with Core 2 for getting middleware to work on the same kind of way as controllers did. Now, the problem with the convention-based way of middleware is that it feels a bit clunky and lays a few bear traps for you if you unwittingly declare transients or scope dependencies as constructor parameters. What the iMiddleware interface does is allows you to turn what we've just described about conventional middleware all on its head. This time, the invoke async method has a fixed signature defined by the iMiddleware interface. While we still get the HTTP context passed into it, this time the request delegate is passed in via the method and not the constructor. So given that the method has a fixed signature, we have to go back to the constructor to inject our other dependencies. Now, what is different this time is that the middleware instance is constructed by the DI container and not some black magic using reflection. So unlike the convention-based middleware, we do need to remember to register our middleware. We do need to remember to register our middleware with the container in the configure services. So given that method has a fixed signature, how do we go back to the constructor to inject our other dependencies? What is different this time is the middleware instance is constructed by the DI container and not some black magic using the reflection. So unlike convention-based middleware, we do need to remember to register our... Oh, my slides are going ahead of me. Sorry about this. To register our middleware with the container in configure services. When we call the use middleware method to register the middleware, the method checks to see if our middleware type implements the iMiddleware interface. If it doesn't, then it assumes it's convention-based middleware. But if it does, it gets an implementation of the iMiddleware factory from the DI container, which in turn calls the DI container to get the instances needed for our constructor. Now that seems like an unnecessary extra hop to go via the factory. But the reason the factory is there is so the other containers, such as AutoFact, can also register their own implementations. Those implementations can then use their own container to resolve the instances directly rather than via the iService provider implementation. So going down this route, writing middleware becomes much more natural as you write it the same way as you would any other .NET class and register it with the .NET container. So it becomes much more natural, a bit like writing controllers, for example. If you're interested in finding out a bit more about conventional versus factory middleware and how they work with dependency injection, I wrote a blog post quite a while ago now, well, in fact, what was that, 14 months ago? And that describes how the two interact differently with the underlying use methods on the application builder class, which is the thing that actually builds the pipeline. So that was quite a sort of fire hose of information. Are there any questions from that?
No, you don't get a
Stunned silences.
No. So reminder to the audience, please ask your questions in the chat and I will forward them. And don't wait to the last. So now it's the second of 3, so all will be in the last part of the Q&A.
Hopefully I'm not leaving people in shocked silence.
No, there's still viewers here. I see the numbers.
Right, in which case I'll carry on unless anyone's just popped a question.
We got one. We got one now. What is the best way to debug middleware?
Right, okay. So it should be as simple as having breakpoints in there. Because if it's in terms of debugging dependencies, is that where we're getting at? Is it debugging dependencies or debugging the middleware itself?
Perhaps age crop. Could you be more? Yes. So what? It's the real middleware or the dependent. So it's an or question. Yes is
okay. Okay. So when I'm debugging middleware, I'm just using breakpoints in things like Visual Studio. If it's about the dependencies, then I'm
about the dependencies.
Yeah, I mentioned about the options when you're in debug mode that tell you if you're injecting things like scoped or transients into singletons, what have you. But if you're debugging it imitating production, it's very hard to do with those dependencies because, as I say, that you get a captured dependency in there. So I don't have an easy answer for that one. It kind of it depends on what you're trying to debug. If it's trying to debug a scope lifetime, then it becomes a bit harder. So sorry, I can't give you a great straight answer on that one. I have to rely on it depends.
In the meantime, we got another question.
Okay.
Is there a rule of thumb when to use transient and when scoped? They seem rather similar, and in most cases, I know I do not need Singleton, but do not know which of these to use.
Okay. So transients are very much throwaway instances, where so if you've only got one class that needs that within a unit of work, you can use a transient. But say for example, the HTTP request, for example, you might that's set as scoped. So with that, you might want to access the contents of that request in multiple classes that are being used within the HTTP request response lifetime. So that sort of means you just get one instance that can be shared between multiple classes within that. So in that way, it is a bit like a singleton, but it's all within, say, that HTTP request response lifetime. Another request wouldn't see the contents of that request. So that's when I would use scoped. Whereas transients, if it's just a one hit of go and get this value from a repository, that could well and it's only used in one place within that unit of work, that could well be a transient. Hopefully that makes sense.
No reaction.
Okay.
Yet.
Okay.
Yes, thank you.
Okay, great. Okay. Any more questions, or shall I crack on?
That was it.
Okay. So earlier I mentioned that you need to be careful with disposables, but now I want to dig a bit deeper into some edge cases. If you remember, when I was talking about singletons, I said that you should hide disposed methods from consumers as the container will take care of it. That last bit of the statement is true in most cases, but as you can see here, there are a couple of extension methods for doing registrations where you can create the instance yourself and the container will not dispose of it for you. If you do create the instance of a disposable class in this way, there's a problem. Namely, there's no obvious re-entry point back into configure services method or the startup class to get a reference to the instance. So why would you take that approach? The reason you may be creating an object in startup is to pass arguments to the constructor where the parameters cannot be created by the container. Now, if it's a simple value, like the example there where it's just passing in an integer, I'll be more tempted to use the expression version of the registration where the disposal will be taken care of for you. But sometimes it may be more complicated than that. In which case, you should maybe consider using a factory. But if you really must do this, there is a get out of jail card. Behind the scenes, there's an interface that is automatically registered by the host called iHost application lifetime. This can be injected into the configure method by adding it to the parameter list. Here you can register a handler for the application shutdown event, which is past the object that you want to dispose of. Now that's fine if you've only got just the one object that needs disposing, but it does get very messy if you've got lots of them. So if you have lots of objects, you may want to wrap them all inside one single disposable singleton that can take care of that for you. Coming back to hiding the dispose method, if you cannot change the class that you want to, or you just can't because you don't own the source code, it does not already have an abstraction that hides the dispose method, you may want to consider one of the gang of four patterns such as facade, adapter, bridge, or proxy. These are all variations of the same theme where you can create some kind of wrapper class to handle the creation and disposal of a class instance. The last point I want to make is a rare one and a code smell. If you have a class that's a control freak and insists on disposing all the instances passed to it, instead of getting the container to create those instances, consider writing a factory and the patterns I've just mentioned. So that brings us to a feature that was introduced in .NET Core 3, but has an issue that's now been fixed in .NET 6. The async disposable interface was introduced to allow disposal of resources asynchronously to avoid deadlocks. For example, streams can be disposed of asynchronously. This worked fine for singleton and transient dependencies, as the container code was updated to handle disposing of them asynchronously. But there was a problem with scope dependencies. As the dependency gets embedded into an instance of iService scope, which only implemented iDisposable, and therefore was when disposed, only calls iDisposable on objects within the scope. Now, this caused an exception to be thrown if the class only implements iDisposable async and not iDisposable. Why is this a problem? Why this is a problem is that whilst the iService scope could be updated to support iDisposable async, this would be a break and change for other containers such as AutoFac and Unity. That would also need to be updated to support this as well. To get around this, a create async scope method has been added to introduce the async service scope class. There's a wrapper class that implements both the iDisposable and iAsync disposable. When the scope dependency needs to be disposed, there is a check made to see if the async dispose is supported and can be used. If not, the regular iDispose method is used instead. What this does mean, though, is that if your class only uses async disposable and not iDisposable, but a custom container doesn't support that, you will still get an exception. To get around that, you also need to implement the iDisposable on your class as a backup to make sure that if it doesn't support iAsync disposable, you can still dispose it using the old style. Next, we've got some gotchas that can come up and bite you when registering or consuming services from the container. Consider what happens when the same service gets registered multiple times against multiple implementations. Now, you may well be doing this deliberately because you have several implementations that you want to iterate over. These might be a set of validation rules or a collection of processing types that form an enrichment pipeline that you chain together using the visitor pattern. But it can happen by accident. For example, you may have a source code merge that's gone wrong, or there may be an extension method registering a different implementation to the one you are registering without you knowing about it. Whatever the reason, there can be unintended consequences because of the way the container works, namely last in wins principle. So if you call an extension method after your registration, it will be the extension method's implementation that will be the last one that gets resolved by the container. So you do need to give some thought as to the order in which you register your dependencies and configure services. Of course, if you're writing an extension method, especially if you're publishing it to a wider audience via NuGet, the onus is on you to play nicely. Now, as we know, there needs to be care around lifetimes and things get messy. If multiple registrations with different lifetimes, or you may think you've registered a singleton, but sometimes someone else comes along and trumps it with a transient or scope because the last in wins. Now, it may be that, as I mentioned just now, you deliberately want multiple implementations. But if we want to avoid accidentally registering the same service multiple times, there are two ways out the box to do this. The first is to use the triad methods, where the first registration is kept and subsequent registrations are ignored. So we flip from a last in wins principle to a first in wins principle. The second approach is to use the triad enumerable methods, where both the service type and the implementation type are taken into account. So in the example shown here, the try singleton will result in just one registration, even though it's been called 6 times. But the try enumerable will result in 3 registrations, as the implementation type is also taken into account. The downside to using triad methods is that each time it's used, there's an iteration over the whole service collection to check for a service descriptor. This means that the more services that are registered, the longer it'll potentially take to check if it has to search the whole collection to establish a registration is not already present. It's fine if it's sort of like the first or second service registered. But if it hasn't been registered and you've got 30 or 40 or 50 or 100 services, that's a huge lot of iterations. Now, a change was made to the way this enumeration works during .NET 6. The change reduces the memory allocations while looping over the collection, but it doesn't improve performance. There were some thoughts within Microsoft as to how to improve the performance by using a dictionary, for example. but they did not make it into .NET 6 due to lack of time to see if the performance would actually be improved by having that extra dictionary and having to maintain it. I had a quick look on GitHub earlier, and the issue to do this has been closed down, but it may still reappear in .NET 7 or .NET 8 timeframe. So that's some gotchas. Now let's look at some helpful hints and tricks. Flipping what I've just talked about on its head, you may be deliberately registering multiple implementation that callers need to iterate over. I've just given a couple of example scenarios just now. If you plan to do this, the consuming class needs to know that there will be multiple registrations. This is done by explicitly requesting an IEnumerable of the service of the type that you want to get all the implementations. If you don't do this, the instance you get will either be the last, if it's just been done with an add, or it'll be the first if you've used a triad. Depends on what's been used on the container registration. If the order of the enumerable is important, then there needs to be a way of differentiating each instance. Without that, the consumer will have to rely on the order that the registrations were performed. There's lots of ways of handling that. One is to create a comparer that implements iComparable interface for your service type. That can then be used with an order by link when receiving an enumerable. You could create a dedicated class that implements the IEnumerable interface, and the caller requests that. But for that to work, you need to inject the IEnumerable of the service type and then have some ordering logic that yields the instances in the correct order. So that's kind of a bit overkill and messy. Lastly, what you could do is register a Lambda expression for IEnumerable in the container that serves up the instances in the required order. Going the other way around, you may have a single class that's got multiple interfaces on it, especially if you've gone down the interface segregation principle route from Solid. If you register the type with each interface individually, each registration creates a distinct instance, when really you probably want the same instance returned, especially if it's a singleton or scoped. If you want to access the same instance through the different interfaces, you should register the instance first by its class type. Then you can use Lambda expressions using the getRequiredService method to resolve the instance from the container and return it via the interface. In some cases, you may want to aggregate the interfaces together into a composite interface as shown here. This may be a benefit if you don't want consumers to be able to request concrete implementations directly. Think back to the iDisposable issue I mentioned earlier, where you don't want the dispose method on the concrete exposed, especially on a singleton. So by having an aggregate interface that covers many other interfaces, they can still call that to say, go and get me the overall thing, or they could request via the individual interfaces. So in the example here, I've registered my implementation using an aggregate interface rather than a disposable concrete class. I've then also registered the same singleton instance against the individual interfaces to retrieve the same instance by calling back into the container to get the aggregate instance. Next, we have open generics, where you define a type parameter on the class type. Now, the place you may be familiar with this is from a DI perspective is the generic iLoggerT interface, where you may be using it in your controller constructors to get an iLogger instance for the type of controller. Similarly, you may be familiar with the iOptions interfaces that get registered when you use the configure method to bind configuration to objects. If you want to register your own generic type, the C# syntax does not lend itself to referencing open generics with a generic declaration. So instead, we have to use the non-generic registration method, where we use the type of keyword to get the service and implementation types without giving a closing type parameter. So as you can see, we've got the round bracket type declaration rather than an angle brackets. Behind the scenes, the container makes use of the generic type method on the type class to create a closed generic type. For example, do something generic of strings. It then uses that type with a bit of reflection magic to create the closed generic instance to return to the caller. Now, if you have not moved to .NET 5 yet, or .NET 6, you will hit a problem if your type definition includes a constraint on the generic type, such as limiting it to being a class or implementing a particular interface. The problem is that the make generic type has been in core 3 was throwing an argument exception. Luckily, that's where Jimmy Bogard of Automapper and Mediator fame has come to the rescue. He did a pull request that added a try-catch block around the make generic type that swallowed the argument exception. This now allows the constraint generics to be resolved in .NET 5 and .NET 6. That's great, except it took 4 years for that pull request to be accepted by Microsoft to go into the main SDK. Now, if you read Jimmy's blog, you get to understand why there's been very little change in the Microsoft container since the first version of .NET Core. In short, you must ensure that all those other container technologies that implement the iService provider interface don't break, which in turn means having to write a whole load of unit tests, not only to show that your change fixes something or adds some new worthwhile feature to the container, but it also have to show that that change does not break those other containers. So I alluded to that earlier when I was saying about the async disposable, that some containers, you couldn't just add another method to the create service scope, because that might break those containers. So whilst at the start of the talk I said I wasn't going to go into detail about other containers alongside the .NET container, I think it is worthwhile mentioning why other containers still have a purpose. The Microsoft container is what's known as a conforming container, which is a sort of fancy way of saying that it only supports the lowest common denominator of functionality. In other words, out the box, it only supports constructor injection. But it also acts as an abstraction that other containers can hook into via a common interface. So you're probably aware that there are a number of other container frameworks out there that can be used with .NET. They also have a number of features in those containers that are not supported out of the box by the Microsoft container. So as we've seen with both Jimmy's pull request and the introduction of handling scoped async disposables, any change to dependency injection does need to be thoroughly tested to make sure that it works with all those containers that adhere to the iService provider interface. Next, I want to talk about a couple of so-called Gang of Four design patterns that are relevant to DI container world. First is the factory pattern, which I mentioned in passing throughout this talk. Now, you may be thinking, surely the whole point of the container is to be a factory, so that why would I need to go and write a factory class? Well, sometimes you do have to give the DI container a bit of a helping hand. For example, you may have a class where some of the constructor parameters are not known until runtime, as they may be captured from user input, for example. In those cases, you can't get the container to create the instance for you, as the user hasn't entered the parameter. The container is completely oblivious to user entry. That's not unless you do some hideous hack involving async local, which is pretty nasty stuff. You don't want to be doing that. It may be that the instance to be created needs to be disposed of quite quickly and is a resource hog. So you want to be able to dispose of the instance as soon as the caller is finished with the resource, rather than wait for the container to dispose of it. Lastly, at the start of the talk, I mentioned that the Microsoft container does not support property injection. But by using a factory, we can effectively simulate property injection by getting the container to instantiate a class, then set the property values on it within the factory method, and then return the created instance back to the caller of the factory method. These are just a few cases where the factory pattern comes into its own. So whereas a very quick and contrived example, we have a class that we will register as a singleton. Next, we're going to go and create a class that consumes that singleton, but also requires a name parameter in the constructor. Now, given that the name parameter cannot be known by the container, as it's provided at runtime by our API controller, we can't add it to the configure services. You may also notice that I've used an immutable class here, but with C# 9, I could have used a record type, for example. Now we will go and create the factory class. First, we will take a singleton and cache it in a field, as shown in the blue highlighted constructor. We then have a creation method that will go and new up our short-lived thing class using the cache singleton and a value passed into the name parameter that we have on the factory method. Next, we add the factory into the configure services as a singleton. And finally, we have our controller. Now, this slide was before I upgraded to .NET 6, so it's still controller based, but the principles are still the same. Our controller takes the factory in its constructor, and later in the get action, it then makes a call to the make method to create a new instance of the short-lived thing. Now, I know that's very contrived, but I wanted to give a flavor of using a factory. And sorry about the small font on there if you're watching on a small screen. There was a lot I had to try and sort of squeeze into that slide. To summarize factories, usually you'll register a factory as a singleton. For most of the time it is stateless. The variations are the parameters in the create method. As it is a singleton, the only other dependencies that should be injected into it are other singletons. If you need transients or scope dependencies, you can take the iService provider itself as a constructor parameter, but proceed with caution. Direct use of the iService provider is considered a version of the service locator anti-pattern. The reason it's an anti-pattern is that it's a tight coupling with the container interfaces, which in most cases you don't want to do. You want to keep your business logic oblivious to what infrastructure you've got in your classes. However, factory pattern classes fall into a group that I refer to as servicing classes. These are plug-in gaps between the container functionality and effectively an extension to the container, rather than necessarily being part of your business logic. So with this in mind, I think that as long as the factory classes are seen in that context, you don't go referencing iService provider wholesale throughout your application, I'm fairly relaxed about doing this, as I think it's about being pragmatic rather than dogmatic. If you're worried about using the factory classes and exposing this anti-pattern and coupling, you could create an interface that makes the private class inside your startup class, for example. That way the container can construct them and only access the methods of the registered via the registered interface. Timely, picture of a drinks machine, and I need a drink. A variation of the factory pattern is the builder pattern, where rather than prescribing which dependencies are needed up front and creating an instance of immediately, the builder pattern is much more flexible. And we've seen it already in the examples. We have the web application builder, we have configuration builders. The way I compare the two patterns is to think of the two as ways of ordering drinks in a fast food restaurant. The factory pattern is like asking a person to serve a cola. They use a standardized dispenser like we've got on the left with a fixed set of options that make standard drinks. With the builder, it's much more like a modern dispenser where you can say, I want a dash of a cola with a bit of lime and a dash of vanilla and some cherry flavoring, and gradually composing a customized version of what you have until the finished drink is ready for what you want. So with the builder, we start off much like a factory by registering it with the container. However, this time we register it as a transient, as you're going to be mutating the state of the builder once it's been created, whereas a singleton is created once, it doesn't change. In its constructor, we can take in other dependencies from the container. Consuming classes, we take the builder as a constructor parameter and then start using methods and properties to build up how the new instance is constructed. Then once we have configured the builder with everything that we want, we can then call the build method on that to create our instance. Typically, the resulting instance will be immutable. You don't want to change once you've created it. If the instance you create out of the builder is disposable, the caller will be responsible for calling dispose method, as that is the thing that's going to call the method to create the instance. The container has nothing to do with it. It's given you the singleton with the ability to go and create an instance, but it's been your code that's gone and created the instance, so it's your code's responsibility to go and clean up after it. Now, so far, we've assumed that the factory or builder classes will be using the new keyword to instantiate a class instance. But wouldn't it be good if we could take advantage of the container to create an instance for us? In the earlier slides, I said that the problem was working out how to populate the parameters that the container does not know about. Luckily, there's a helper class called the Activity Utilities class that comes in handy with this. There's four methods that are effectively two methods with generic overloads. The get service or create service method will try and get the container to create an instance for you, but if the type is not registered, it will try and do it using reflection. The other method, and the one that is of interest to us as writers of factory or builder classes, is the create instance method. What this does is it takes an instance of iService provider to get an inroad into the container, and then it takes an array of objects. What it then does is it does a bit of a shuffle to work out which of those parameters to the constructor can be fulfilled by the container, and which need to be fulfilled by your factory method. Now, the downside to doing this is that you may take a performance hit when it's trying to do this matching up process, because it's got to go over all the different parameters and work out where it can populate them from. But where this is useful is for our factory or builder is that instead of explicitly declaring the types that we want to get from the container and then adding them in the other parameters from our create method, we can get the activator utility, to do the heavy work for us. So, deep breath. Before I move into the final section, are there any more questions in chat?
Yes, we got one from Stefan. But he's not sure if it fits to the agenda. He remembers that add options and validate data annotation did not instant validate a config. Does anybody know the reason for such behavior?
Remember that add options and validate did not instant validate config. Do not validate a config. So that is less of a DI question. That's more about the configuration itself. I think that's related to the configuration builder pattern. So add options was done to support the I options, where you can do the binding and get automatic binding. Didn't validate a config. I'm afraid I'll have to pass on that half, because validate data annotations should kick in. But I think I'm right in saying in that it won't actually do that validation until that configuration is needed the very first time. I suspect, unless anyone can advise otherwise. So I think that might be it. Because if the configuration isn't called straight away, then that validation won't kick in until the first time it's called. And the dependency injection container actually goes and creates an instance of that particular class. I think that's possibly where the problem may be.
Yep. Stefan, let us know if you found it out.
Okay.
Good, but that was it.
Okay. Right, you'll be pleased to hear we're on the final run now. I'm almost out of voice now, so we're on the final set of slides now. Let me just click on this. So we're in the final section at last. In this section, I want to talk about plugging in some of the gaps of functionality that the Microsoft container is missing. I mentioned earlier that property injection is not supported out of the box by the Microsoft container. And as I alluded to earlier, you can get around this by using a factory or builder pattern that will go and create the instance using the parameterless constructor, and then going and setting the properties before returning the instance from the create or build method. Another place where this may be useful is where you need to go and create instances of struct value types, where some of the properties come from the container. The problem here is that you simply cannot register value types with the DI container, as it doesn't support it. It only supports reference types. So you need to get all the dependencies and instantiate the value type yourself. So here you see I'm attempting to add a struct type registration using the generic add transient. And here's Roslyn Analyzer error to tell you that you just can't do that. It's a struct. It's not possible. So you may think, aha, it's because I'm using generic registration. I'll use the non-generic type. And that's great. You don't get a compile error. But what does happen is you kick the problem down the road to become a runtime error. So how do we get around this? It comes back to simply creating a factory or builder again that takes the parameters needed to populate the value types. Now, the example here is contrived again and offers no benefit over just creating the object in your own code. However, if some of the properties need to be taken from the container, this is where the factory can grab these from the constructor or via the IO service provider and put them together with the method's parameters. Which leads us to, I say new C# 9, cool, that's been around for almost 18 months now. I'm a big fan of these, but we've been making heavy use of them. For those not familiar with these, these are reference types like classes, but they behave like value types when it comes to equality checking. They also offer a simplified syntax for immutability. If you want to find out more about them, I like the on.net show video that's shown here that's available on YouTube and on Channel 9. From a DI perspective, because they're classes, well, in C#9 they were based on classes, but in C#10 you can now have struct-based ones, but we'll put that to one side for the moment. You can still register them with the container. However, given that record types are mainly for use as entities, GTOs, you're more likely to use the factory pattern for the same reasons I gave in the previous slides. If you're interested in finding out more, I do have a blog post that shows how to write a record factory, which also covers a lot of things that I talked about earlier about writing factories in general. Next, we have something no one really talks about with using dependency injection in C#. We nearly always talk about classes and interfaces being registered with the container as service types, but delegates are also a first-class citizen and can also be registered. Now, in theory, you can register the anonymous delegates from the funct family, but these are hard to distinguish from each other as they are generic. So instead, we go back to old school to something that doesn't get much attention these days, and that's custom delegates. I go into details on my blog, but I'll give you a quick example. Now, I hate system date time now property. It's non-deterministic by its very nature of being real time, which means you can't really unit test it and do anything like that properly with it. But what we can do is create a delegate function that will call the system date time now property on our behalf. The signature of our delegate in this case is a function with no input parameters and a return type value of date time. By creating the delegate, we are creating an abstraction without all the ceremony of having to first create an interface and then create an implementing class that then wraps the dreadful static property. This makes your registration code much cleaner as you don't need all that plumbing. It also feeds into the single responsibility principle as a delegate does just one thing. And it's not a million miles away from the thinking behind minimal APIs. When you think that a minimal API is just a handler that takes in some input and returns a response. If you want multiple date time related functions, you may still want to write an interface in the class. But if those functions don't share any logic, you could just create multiple delegates. This is where the custom delegates have the advantage over the funct family, as the delegates can all have the same signature but are distinguished by a delegate name, because it's a bit like having different class names. If you do try this with the funct family, then they may have the same function signature and you fall into the multiple registrations trap that I mentioned earlier in the talk. From a unit testing point of view, the delegates are very easy to mock or create your own implementations, as they are just, in this case, functions that return a date time value, for which a unit test you can just mock up the value. You can set a fixed value or then just check it in the asserts. Now, you may notice that I've registered the delegate as a singleton and may be thinking that the date time returned will be captured the first time it's called, because I said watch out for things that change being captured in singletons. But that's not the case, as we're capturing the delegate, not the delegate's result. So we're capturing the definition of what the function is as an object, not actually calling it and capturing the result. It's not until you invoke the delegate that when you actually need it, that you get the result. So this is the same principle that's used in the middleware pipeline that I covered earlier. So in this example, I consume the delegate in the controller constructor and cache it in a field. I then invoke it at the time that the constructor is run and cache the result in a field. In the get action, I then force a 3-second delay. I then call the delegate again and create a return string with both values. Now, as you can see from the result shown, even though the delegate is a singleton, the result generated is not generated until invoked. The first invocation is in the constructor, and the second is in the method, and hence the 3-second difference in the result shown in the bottom there. A feature that is supported by other containers, such as Autofac, is being able to specify a dependency to be resolved by the container using a string or name or key. It's considered a bit of an anti-pattern, as it comes back to the idea that your application code should not know about the container's mechanics. But what if you could do it without your class having knowledge of the container? So this occurred to me quite a while ago now, when I had a situation where the type of mapping algorithm to use was determined at runtime based on a value that I was retrieving from a database. Rather than massing a massive hard-coded switch statement with hard-coded classes inside a repository class, for example, that would need to be updated each time a new value came along, I wanted something that could be injected from the container to just give me the mapping functionality I needed. Now, it's a bit long-winded to describe here, so there's a link to my blog post. But to give you an idea of what's involved, I have an example. Here we create a common interface and some classes. So here we have a temperature converter that converts between different temperature scales and kelvins. We then register them all with the container as their actual types. And then following on from what I was saying about using delegates, we also have a delegate declared that takes a string that returns the required implementation of the I-Kelvin mapper interface. Now in the code here, I've used a simple switch statement based on a character value, but I could have done something more advanced with using a dictionary or possibly custom attributes on the implementing types, or maybe even C#9, C#10 pattern matching. Whatever way you choose to do it, the delegate is the secret sauce as it allows us to lift the logic out of the consumer and then up into the controller, or potentially, if you're using minimal API, into the handler parameters. The consumer will use the delegate to pass the string and then get back the correct mapper instance that it then needs. In other words, we have something along the lines of an abstract factory pattern. So now we have a consumer class called getTemperature that has a method to take a scale as a string and a decimal value that uses a delegate to convert to the kelvins. Our class has no knowledge of the container's iService provider, so how the required implementation gets chosen from the string. It just knows that it will get a converter instance back based on the string value it passes in to call the toKelvins method. Decorator is another gang of four pattern that can be used to extend the functionality of a class by wrapping it and then re-implementing all the members. But where necessary, intercepting the incoming parameters and the outgoing result to do something. Now, a common example of where you would probably do this is to add a logger, so that every call to a method's input gets logged and every outgoing response also gets logged. To do this, though, we still need the original class to be injected into the decorating class, along with the other dependencies, which in our case is a logger. So in the example code here, we have a class called doSomething that implements IDoSomething. First, we register the class as a concrete type and not through its interface. We then have a decorating class called loggingDoSomething that takes the registered original class and also requests an instance of iLogger. It then re-implements the getHello method again, this time with code that intercepts the input and output of doSomething's version and writes these out to a log. We then go back and register the new loggingDoSomething against the IDoSomething interface, which is used by the consumers. So that way, instead of registering doSomething against the service, we register the decorator against the service. Callers are completely oblivious to the original concrete method. The last missing feature from the Microsoft container that is supported by the containers is registration of services by convention and assembly scanning. Now, I'm not personally a big fan of doing this, as I'm a bit of a control freak and I like to know exactly what's going on and what I'm registering and what services are going to be set up in the container. But as we saw earlier, it is possible for registrations to stamp all over each other depending on the order that they're registered. And that's another reason that I'm not a big fan of this automated approach. However, if you do have masses of classes across multiple assemblies that you want to register, that could be quite a laborious process. And I totally understand why you may want to be looking for a shortcut. There's several offerings out there, but probably the most well-known is the Scruter package, where you can define rules of criteria for registering classes and interfaces. One nice thing I do like about Scruter is I've just been talking about decorating classes. It has a nice simple syntax that rather than doing the hand-cranked version of writing your own code to go and wrap some classes, it can automatically create stuff on the fly for you. So you don't have to go through all that code that I just showed just a minute ago. And that just about wraps it up. I've just about got a voice left, so one quick sip of water. Thank you for coming to my talk this afternoon. I hope I provided some value, even though it may only be 1 or 2 gold nuggets of information. I hope I haven't sort of just gone a water hose of tons of information. I'm not Andreas, is this being recorded?
Yes, this is
So,
recorded.
so you may want to go back and watch it at half speed if I've just bombarded you with information. If you do want to hear any more of me rambling on, sort of double speed talking, I am on Twitter quite a bit, and I do have a blog where I write mainly about dependency injection and configuration. In this final slide, I do want a few honourable mentions. I've been working the last week to bring in the .NET 6 stuff over my original .NET 5 talk. And every time I'd Googled something about what was changing, I kept coming back to a brilliant blog series by Andrew Locke, who goes into an awful lot of depth about what has changed between .NET 5 and 6. I think it's something like about a 12-part series. It's really, really good. I highly recommend going and looking at it. He's also published a book about ASP.NET Core with Manning, and that's well worth reading as well. The Microsoft doc pages are well worth a look. These have been updated to the more modern .NET 6 way of doing bootstrapping dependency container. So if you're still in .NET 5 or migrating stuff from .NET 3, for example, you may want to use the drop down on the page to go back to those earlier versions to see how it was done there and then compare it to the new .NET 6 version. Last by no means least, Mark Seaman's blog and book are well worth looking at to get a bigger picture of DI outside of Microsoft's container. He's got various thoughts about it and always got an interesting person to read. With that said, I've just about still got some voice left. That's the end of the talk. Thank you for listening to me. And I'm happy to try and answer any questions.
Yeah, so there's first thing to the question of Stefan. That was exactly right what you said. So he tried it out. Then we have from another Stefan from Flashware a question. He was wondering if with C#10 we now may actually do register structs with the type overloads of add and with add star type in.
Oh, that's an interesting one. That is an interesting one. Let me just bring that here so I'm facing the camera. See, I actually do register structs with the type overloads of add star. I would have to go and experiment. I think the ones that are based purely on structs would still have a problem because I think there's some code deep down in the container that works out if it's a reference type or not. And if it's not a reference type, I don't think you can register it. So that's why I had the factory for structs as opposed to just being able to register them. But the point about C#10 now allowing parameterless constructors, it'd be interesting to go and have a dig around in the container code to see whether they've made any changes to allow for parameterless constructors on there or not. I would have to go and have a dig around, Stefan. But my gut feel is that if you use the new C#10 syntax to create a record based on a struct, my gut feel is it probably still won't allow you to register it.
Time for experimenting.
Yeah, I'll have to have a go and play with that tomorrow.
Good. Last chance to ask questions to Steve. Until we wait, small surprise. All of our speakers get a custom .NET Devs AT coaster.
Oh, thank you.
And I will send it to you.
Oh, thank you very much.
Days. Yeah, as a small thank you. Every speaker gets one.
Great, thank you. Appreciate that.
Good. And yeah, no other questions here. So let's go to the outro. Yeah, Steve, thank you.
It's my pleasure. Thank you for having me and inviting me.
For sharing your knowledge with us. Also thank you all to our viewers for joining. And thanks to our sponsors, which made this possible. Rubicon, Data and JetBrains. And this brings me to the giveaway tool. So we have 9 entries. Last chance to enter with # JetBrains in the chat. to get one. 5, 4, 3, 2, 1. Let's see who wins the license. Samo Milan, congratulations. Please reach out to me at team@.netdevs.at. I post the email address in the chat. And I will send you the license in the next days. Yeah. Also, as you said, we will going to in-person events in the future. So if you want to host the meetups somewhere in Vienna, please reach out also to us. Yeah, we need locations. Plan is for the next meetup. The next one will be a little bit longer on May 31st. We got Andrew Knight, also called the Automation Panda, and he will talk about Boa Constrictor. It's a library to bring the screenplay pattern to the dead. Very cool stuff for UI and REST automation for tests. Yeah, please spread the word that we have these monthly meetups. Invite colleagues, friends, customer. Read with our stuff. Invite everybody you think has to do something with .NET. We always can learn something. Again, our links where we are available in the chat. And now the last thing, we always want to improve our meetups, and for that we need our feedback. So please fill out this form. Shouldn't take too long. And there you can also enter at the end if you want to win of the Hey Friends t-shirts. And with that, yeah, once again, Steve, thank you.
My pleasure. Thank you for having me.
We see us in the next one. Bye.
Bye.